So, hello everyone, also from my side. My name is Steliyan Vasilev from 3E Smart Solutions. We are an internal in-house engineering office of ZSK embroidery machines, and we focus on the product development in the field of smart and e-textiles. So, my presentation will focus on especially on embroidery. We saw in the last presentation multiple different ways to produce smart and e-textiles, and from this presentation, I want to give you more in-depth insight into the embroidery technology and also to share the opinion of Madison that there is not a best technology to create smart textiles. It's always application specific, and maybe in one or the other project we need to integrate or to collaborate with different technologies to create the optimal solution. So what has embroidery to do with e-textiles? Well, you can see some example applications on the screen, and if you come to our booth, you can also see most of them there. It's basically the booth with the two dogs. You'll find us against the reception. So yeah, embroidery has pretty much to do with smart textiles, and this mainly because it offers solutions like we can integrate electrical components and PCBs directly to textiles in the same production step. We can embroider full electrical circuits by combining these electrical components with external circuitry or power sources. We can integrate conductive fibers, wires, or tubes into textiles, or we can embroider or fill areas that can be used for capacitive sensors, other kinds of sensors, electrodes. And embroidery offers the following benefits. We're very flexible when it comes to design, so everything that is in the two-dimensional space can be basically created with embroidery. And maybe one of the main advantages is that we preserve the properties of the textile. So the e-textile product would remain flexible, have draping properties, and be breathable. Also, embroidered e-textiles show to be durable, and they can be washed multiple times without affecting their function. As I mentioned, we can directly integrate electrical components with embroidery machines because they're computerized nowadays. So they're basically CNC machines, and we have a very high degree of automation and easy scalability, as everything that can be produced on a single head embroidery machine can also be produced on a multi-head embroidery machine. So how do we create an e-textile with embroidery? We take the embroidery machine, of course, we need it, and we add the electronic components by means of conductive threads that we use for our conductive traces. So, of course, we attach these to a carrier material, mostly textile. And here I show you how a typical embroidery machine looks like. This is a ZSK JGVA machine, which is a typical development machine, which has all the technologies combined. So we call them F, K, and W head. So the F head is basically used for normal embroideries like logos, for example, but when we use conductive threads, we are able to achieve conductive traces or field areas, and also by means of some additional attachments, we can automatically apply functional sequence or even whole PCB boards. The K head is used for the moss or chenille embroidery, and again, by means of conductive threads, we can create three-dimensional structures with a very high surface area, large surface area, that are ideal for electrodes, for example. And the W head is used for the placement of wires, fibers, and tubes. So what are the challenges related to the e-textiles production that we see and that we try to address? we think that they can be related to either the reliability of the product or its mass producibility. So when we talk about reliability, we can break down the challenge into different stages. So let's say on the one hand side, of course, maybe main issue is the connection between the soft material and the rigid and hard PCB or electronic component. On the other hand side, we have the embroidered conductive traces that also face some challenges, like we have a high resistivity of the conductive threads that we use. We are trying to avoid the damage of the conductive thread during the embroidery process itself. And of course, we need to enable the intersecting or insulation of the conductive traces. And of course, to make it easier or defined or more appealing for the industry to produce this kind, we need some kind of standardization. So I'll talk how we address these challenges one by one. So talking about the reliability of the embroidered connections, here you can see on the pictures, these are some PCB boards that we started with. They're off the shelf, like the well-known lily pad. And first we tried to optimize the stitch parameters, so stitch placement or numbers of stitches, and we were able to improve the reliability of the connections to a certain extent, but we wanted to go a step further. And we figured out that the geometry of these PCBs is actually not really suitable for this purpose because they were not developed to be embroidered, of course. So what we did is we developed basically a set of guidelines for the geometry of the PCB to make it more suitable for embroidery. Like these guidelines or rules, they are related to the geometry of the holes that we try to embroider, to the thickness of the PCB edges. And then coming to the second point, the yarn resistivity. Normally we work with silver-coated polyamide yarns, which have a resistivity up to few hundred ohms per meter, which can be quite a lot for certain applications. So what embroidery allows us to do is, of course, to add more material, like embroider multiple passes on a conductive trace, and this actually would work like a parallel resistor circuit, and we're able to reduce the overall resistivity of the trace. So here on this picture you can see how an embroidered trace would look like in the programming software of the embroidery machine that we call punching software. And also beneath there is a close-up picture of an embroidered trace. These are both with 4 passes. Coming to the insulation, we have different ways. So on the one hand side, we can use embroidery with non-conductive thread to cover the conductive traces, which would give us some mechanical protection. Maybe we can match the color to our design, or to prevent the direct contact to the skin, for example, for electrodes outside of the electrode area where it's not desirable. But of course, for waterproof, for applications that need waterproofing, we can use some seam sealer or like polymer coatings to completely insulate the trace. Coming to the standardization topic, we are actively participating in the IPC Standardization Committee. My colleague Melanie Ho, who is also a lead development engineer at 3E Smart Solutions, is a chair of the IPC Standardization Task Group for Embroidered E-Textiles. Coming to the challenges for mass production. So mass production, I would like to split into automation and scalability. So when it comes to automation, I mentioned that embroidery machines are fully computerized, so basically CNC machines. And here are some examples what is possible. For example, with the K-head, as I mentioned, we use it mainly to create three-dimensional structures that can be used to achieve certain haptics or electrodes that are worn close to the skin for biosignal acquisition or electrical stimulation. With the W head, sorry, we can lay wires, fibers, tubes in predefined geometry to achieve applications like heating, illumination, RFID antennas, sensors, and many others. As I mentioned also, we have additional attachments that are not typical for normal embroidery machines, but they allow us exactly for the creation of e-textiles to automate the process of integration of functional sequence or PCB boards. So on the left-hand side here, you can see the ZSK functional sequence device, which allows us to place small flexible PCBs, for example, with LEDs or other SMD mount components, maybe RFID chips or temperature sensors. And on the right-hand side, it is the ZSK PCB placement device, which is capable of placing even bigger PCBs that can be more complex. Coming to the scalability, as I mentioned, everything that can be embroidered on a single head machine can also be embroidered on a multi-head embroidery machine. And here I have some examples for you. So this is a 6-head embroidery machine with 6 functional sequence devices for placing LED sequence. In this case, we were part of the micro textile factory at the TechTextile conference or show 2019 in Frankfurt. And here is another 6-head machine for wire laying. In this certain application, it's for car seat heating. And these, when it comes to production, are still considered small machines because there are possibilities to create machines with up to 56 heads, so you have basically 56 parts done simultaneously. All right, so here I want to provocatively compare embroidery and printing and try to see what would be the best technology. All right, so what are the advantages of embroidery? We have higher durability maybe. The e-textiles can be washed. We can integrate electrical components in the same step. The products are breathable, and we can create three-dimensional structure to achieve certain haptics or electrodes. Printing, on the other hand side, would offer a higher resolution, so we can print finer details. We can use stretchable substrates. We can print multiple layers on top of each other, conductive or insulating. And maybe they would be more efficient and cost-effective for covering larger areas, because if we use embroidery, it would be a lot of stitches, which is a lot of production time and a lot of material. But as I mentioned at the beginning, probably we are not supposed to compare those technologies in terms of what is better and what is worse, but maybe try to consider all of them for our projects and work together to find the optimal solution for a certain application. So who is 3E Smart Solutions? Well, we are a small team focused on the product development and consulting around smart and e-textiles with a focus on embroidery. And we also offer workshops and trainings that are customized to our customers' needs. So basically, if you have an idea, but you are not sure how to realize it, how to start, you can come to us and we will assist you from the initial idea to the final product. Thank you for your attention, and feel free to visit us at our booth again, the one with the dogs. So I'm looking forward for your questions.
Thank you very much for the nice presentation. So are there any questions? Please.
I just wanted to ask what applications you're seeing are the most popular so far for embroidery technology.
Well, so far from our experience, heating would be one of the most popular technologies, maybe because it's the simplest one from engineering point of view. A lot of car seat heatings nowadays, or steering wheel heaters, they are produced with embroidery. Another technology that is gaining more popularity and we are working more intensively on lately, these are the embroidered electrodes. So they're interesting for the medical, sports, fitness, wellness. So these would be like, people appear to be a little bit more skeptical when it comes to the integration of PCBs yet, but we're doing our best to prove that these are reliable, or to even improve the reliability even further.
Yep, please.
I might have a quick question with respect to the wire laying. Is there a kind of a specific software you use for the design process? The question comes from the fact that if you just lay the wire in a straight line and someone sits on that, the wire typically may break, so you have to provide some kind of stretchability to that.
Yes. So when it comes to the embroidery machines themselves, we use the normal programming software. So basically, you would have a drawing, which you then would transfer to the software, and you would repeat the geometry with the embroidery machine. But as far as I know, and this is also a topic that's very interesting for carbon laying, because carbon fibers can also be laid with the same technology, and there are some simulating softwares. I haven't personally worked with them, but I know that our customers are using them to calculate exactly the amount and the orientation of the fibers, so that they can achieve a certain mechanical properties at the end. So I would say that this kind of software and simulation could be used also for the heaters. Yeah, but from the machine point of view, we just use the normal one.
And I've got one question. So for the PCB guidelines, do they, can any PCB manufacturer implement your PCB guidelines, or are there very special requirements?
No, they're not special. So basically, we tried to adapt them to what the ordinary PCB manufacturers are capable of. So, yeah.
Okay. Well, thank you very much. Let's thank the speaker one more time. And yeah, they have a very nice booth almost right at the entrance.